Newton's laws of motion. In the history of the world, there are lots of great men and women of great minds and accomplishments. Among these great men was Isaac Newton, an English physicist and mathematician who stood out in the description of the relationship of body and motion. In 1642, Isaac Newton was born. The world witnessed a miracle, and that is a brain that in the year 1687, he published a book which he titled Philosophia Naturae Principia Mathematica, where he formulated the laws of motion, which are the foundation of classical mechanics as we have it today. His book helped us in the world to change our perspective of the world as far as bodies and motion relationships are concerned. In his book, he explained his perspective of the world in terms of bodies of motion, and he explicitly put up a very good argument and reasoning to enable us to understand the cause and effect of forces, gravitational forces, and of course, the relationship between bodies and motion. The laws he puts in our face 300 years ago is still very relevant today and is serving us as the engine of discoveries for many of our life comforts. These laws are referred to as Newton's laws of motion. I need to discuss this law here so that in subsequent lectures I'll be able to refer to the laws to talk about an invention that physics has done in recent years. Now, let's look at first law of motion itself. Looking at it, what did it do? It discusses the physical example that we can see around us. And it states that a body at rest or in motion at a constant speed in a straight line will continue at rest or keep moving in a straight line at constant speed unless it is acted upon by an external force. In simple words, if an object or body is stationary at a point or a position, it will remain at that position undisturbed until another body or object displaces it. Consequently, as soon as a force is applied to disturb the object at rest, the object will continue to move and will never stop until and unless it is impressed or disturbed by another force. This law is also called law of inertia, and of course the literal meaning of inertia is the reluctance of the body to move from a stationary point. A good life example is the rocket that carries materials to the space, material and men. If it is fired from the launching pad and accelerating upwards, it will start slowing down at a stage when the law or when the force applies to it has decelerated, and the usage of that principle will be explained clearly in the next lecture, where I'm going to discuss how rocket works. Now consider football in a soccer game. When the footballer kicks a football at rest, the ball will continue to move until it is either stopped by another footballer or a barrier or even air resistance, however far it travels. This is something we can see ourselves and relate with. Similarly, tennis ball also exhibits the same characteristic, but what we observe is that between tennis balls and football, one can travel faster than the other, and this is because of the difference in mass. Another example is skating. A skater will continue to coast and go smoothly until such a point when law of friction happens between the tire of skateboard and the road, which eventually make the skateboard slow down, and whoever is riding skateboard at that point need to re-energize and start the journey all over. Now let's look at second law. Second law states that when a constant force acts on a massive body, it causes it to speed up, that is, to accelerate at a constant rate. In simple words, a force applied to an object at rest causes it to accelerate in direction of the force. Now the formula F is equal to ma, where A is acceleration and m is constant mass. It beautifully describes this relationship, and you will see a lot more of this formula in some of the calculations that will be done under the working of rockets. In plain language, the amount of force defined and required to move an object is dependent on how big or heavy the object is. The heavier the object, the more force you need to push the object. So, and when the object starts moving too, the acceleration is going to be greater than the smaller object. So let's consider this example. If you try to throw an object from a distance, for instance, a bowling ball, you see that you need a fairly high amount of energy to throw it. And of course, it also moves faster, validating our law. Please put this in contrast with trying to, throw a balloon in an horizontal direction. You discover that the balloon will slow down very quickly because of the friction, air friction. And of course, the force you need to throw balloon is very, very limited. The use of tractors. Also consider the use of tractors. Tractors are used to excavate and move heavy objects in construction sites. It's also used in mining sites to look for raw materials. Now, the tractor moves slowly, and the object being moved is excavated, and pulling it away is also done in a sluggish manner. However, if the same tractor is used to clear bush or clear snow, for instance, you will see that you need less effort to move such material. Now, let us look at third law. The third law states that for every action, there is equal and opposite reaction. The law is apt and easy to visualize and understand. Of course, even in sociology, it is agreed and believed that whatever you sow, you will reap. If you do something from your side, you will receive exactly the result of that thing, from the other side. An example and a practical example is a country or a government or politician who, provide qualitative and mass education for its youth. Such government will expectedly, get the reward of whatever it has done in some years to come. And that is the reaction to the force of money and material spent on education. Now, let's consider another example. If you push an object, precisely the stronger ones, consider you going to the wall of your room and you want to pull it down. What you discover is that it will be very hard for you to do. The kind of reaction you are receiving that is making you uncomfortable and making your hand very aching is that of reaction that the wall is placing on you. Now, let's look at the example of a bucket of anything like materials and water. It depends on the level of material you put in such a bucket. If it's heavy, when you carry it, you will witness very serious strain on your hand. This strain will be so bad that sometimes it feels hurtful. What happens is that the force you apply to the bucket is also applying it downward on your hand. Therefore, the reaction probably most of the time is even greater than the action in this case. So you'll not be able to carry it. If you are, that means you are able to use, your action, and the same reaction equals out. Probably you have a better force, and then you bring it up. Now, this is also a very good example I like to give, and that is of a bird. If you are a good observer of how bird flies, you will see that birds actually presses down the air, apply force, and while you are pressing down the air also presses up the wings of the bird. Therefore, the bird continues to fly higher and higher. Let us look at the example of our domestic carpenter who hit nails into the wood. Ordinarily, hitting nails is supposed to be a one affair thing. But however, you discover that while hitting the nail, this process has to be repeated repeatedly. And the reason is that while this process has to be repeated continuously, hitting nails into the wood with hammer, the nail does not go easy because each time, whatever force you apply, equal and opposite reactional force is being applied to the nail. So, you need to repeat this several times before you get your wood bored. Now, finally, Let us use at the example I earlier mentioned of putting a heavy metal on our desk. And I already told you that the desk will also return a reactive force to whatever you put on top of it. It is only when whatever you put on top of your desk is bigger and heavier and has excess force over and above the reaction force that the desk is supposed to provide, that your desk will collapse. Another example and several other examples exists for you to understand the position of laws of motion. Of course, pushing of barrow, mowers, and all these activities that involves pushing and pulling, are also part of, law of motions that Newton was able to give us. I hope I'm able to give you sufficient example which you will need to think about very well while I do my next lesson on rocket science itself. And the aim of that lesson is to make rocket science as simple as possible so that going forward, you can be proud to say it anywhere that you know what rocket science is all about, and that you can also even be a future practitioner in the field of rocket science.